for the Ethiopian Educational Information and Communication Technology presents Educational Satellite Television Programs.
Hello, teacher. Hello, students. Welcome to today's lesson on some important compounds of selected nonmetals. We will be learning about several nonmetals over the next few lessons, but today we will start with ammonia. In our last lesson, we learned about how silicon is produced from its compounds, silica and silicate. We learned about the chemical properties of silicon, and we discussed some of its uses. In today's lesson, we will explain the steps in the Haber process, which is the method used for the industrial production of ammonia. We will also discuss some of the uses for ammonia. Students, if you are ready, let us begin. The Haber process is used to industrially produce ammonia. This process was developed by German chemist and Nobel laureate Haber Fritz. Fritz is also known for his work as the chief of the German Chemical Warfare Service. He directed the chlorine gas attack at the Second Battle of Ypres during the First World War. In 1913, Fritz discovered the process for synthesizing ammonia by the direct combination of nitrogen and hydrogen. In the 1930s, German chemist Carl Bosch began using the Haber process commercially. Thus, the process is often referred to as the Haber-Bosch process. So, how does the Haber-Bosch process work? Students, let us go through the steps together. First, nitrogen and hydrogen are pumped into a reaction chamber at high pressure. A heating coil raises the temperature of the nitrogen and the hydrogen to about 450 degrees Celsius. It is much more economical to use higher temperatures for this process, even though this condition gives a lower yield of ammonia. The heated gases are then passed over a catalyst of finely divided iron, which improves the efficiency of the reaction. Ammonia is formed in a reversible reaction. Students, what conditions are required to get a high yield of ammonia? What are the most economical conditions for acquiring ammonia? Discuss these questions with your classmates.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Welcome back, students. I am sure you had a great discussion with your classmates. Did you discuss Le Chatelier's principle? I am sure you remember that Le Chatelier's principle is used to predict the effects that a change in conditions will have on chemical equilibrium. If a chemical system is at equilibrium and there is a change in temperature, volume, pressure, or partial pressure, then the chemical system will shift to counteract this change in conditions. As a result, a new equilibrium will be formed. Therefore, according to Le Chatelier's principle, high pressure and low temperature are needed to drive the reaction of nitrogen and hydrogen to the right to form ammonia. A low temperature provides a higher yield of ammonia, but the reaction is slow to reach equilibrium. This is why iron is used to catalyze the reaction. A high temperature will push the chemical system to equilibrium much faster and more economically. However, less ammonia will be produced. After the ammonia is formed, the hot nitrogen, hydrogen, and ammonia are then sent to a cooling coil. At this coil, the ammonia gas condenses into a liquid and is collected. The leftover nitrogen and hydrogen is recycled and pumped back into the reaction chamber. Ammonia can also be prepared in the laboratory. This is accomplished by heating ammonium chloride with sodium hydroxide. Students, write a balanced chemical equation for the formation of ammonia by the Haber process.
Students, let's get ready. Begin. Time's up. Let's get back to our lesson.
Hello again, students. Ammonia is prepared industrially with hydrogen and nitrogen using the Haber process. The balanced chemical equation for the reaction looks like this. Please compare your answer to the one on the screen to make sure you are correct. Ammonia is one of the world's most important industrial chemicals. It is a colorless gas that has a very strong odor. In its gaseous form, ammonia is very soluble in water. This is because ammonia molecules are polar. I am sure that you remember ammonia molecules that are able to form hydrogen bonds with water molecules. At minus 33 degrees Celsius, ammonia can be condensed into a colorless liquid. It has a very high heat of vaporization and convenient boiling and freezing points. Ammonia is mostly produced to make fertilizers, but it is also used to make explosives such as nitroglycerin, nitrocellulose, and trinitrotoluene, or TNT. Ammonia has also been used as a cooling liquid in refrigerators. In today's lesson, we learned about the Haber process, which is also referred to as the Haber-Bosch process. We learned that this is an industrial method of producing ammonia, and we went through the manufacturing steps. We also learned that ammonia is an important industrial chemical that is used to make fertilizer as well as explosives. And this brings us to the end of our lesson for today. Until next time, thank you, teacher. Thank you, students.